What is a cable-driven robot and how does it work? What can it be used for? At this research facility near Montpellier in southern France, a unique test is underway. A mock-up of a heavy plane wing is being transported by an automated cable-driven robot.
Cables are very flexible components. They can only draw the platform, they can't push it. So one of our challenges is to keep the cables tight. The basic principle of a cable-driven robot is very simple, but if your goal is to perform a certain number of demanding tasks, like going fast, holding heavy loads, or being very accurate, that's a challenge. To address those challenges, we turn to maths.
The prototype has been designed by scientists at a European research project aimed at developing robots customized for the automation of large-scale industrial tasks. And they can be easily modified for different jobs.
The robot we have here, for instance, stands on 4 columns that hold its whole structure. But we could also have 3 columns, or the columns could be placed at distances other than the ones we have here. Modularity also implies that we can play with the mobile platform. The one we have here has a cube shape, but its shape could also be a trapeze, or we can attach the cables directly to the piece we want to move around.
We've adapted our attachments to this piece. It's flat, so we had to calculate the best position for the cables to be attached so that we can easily move the piece along the 3 translational and rotational axes in the space. That way you'll be able to work on a large surface in the safest possible way.
Parallel cable-driven robots can multiply by 10 the payloads and workspace provided by conventional industrial robots, researchers say. And that offers huge advantages to manufacturers of heavy lifting systems.
These cable robots are complementary tools to cranes, hoists, chains, or other handling systems. They can be extremely precise in their movements. They can easily move large parts of huge structures, so they can help in mounting these structures.
It took researchers 3 years to develop the complex network of software tools needed to design the layout and geometry of the cable robot. They then had to design the control algorithms needed to manipulate it. Now they're looking ahead.
We're currently working to improve the robot's accuracy. A second evolution would be to test even bigger robots. The bigger the robots, the more complex the problems we have to address. But in the future, we'll need bigger and bigger cable robots, since we're targeting sectors like aerospace and maritime transport.
Europe needs to keep its industrial production, not to outsource to countries with cheaper labor costs. But for that, we need to reduce the manufacturing cost here. And the robotization of industrial manufacturing is key to increase that European competitiveness.
The researchers believe a robot like this one could become a working reality in less than 2 years.